The NASA scientists who repaired a spacecraft from 15 billion miles away. The Voyager 1 is known for being the first spacecraft to go beyond our solar system.
For over 4 decades, Voyager has ventured into the cosmic abyss, pushing beyond the familiar into the great unknown. But as it reached the edge of our solar system, something baffling emerged. Mysterious energy fluctuations, a sudden shift in space's very fabric, and signals that defied explanation. Then came an unexpected transmission, one that sent shockwaves through the scientific community. But what did Voyager uncover in the vast interstellar void? Why was the solar system's boundary nothing like we imagined? And what was hidden in that eerie final message? Let's find out.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The grand journey of the Voyager probes. In the late 1970s, an extraordinary alignment of planets unfolded, an event that occurs only once every 175 years. This rare positioning of the gas giants on the same side of the solar system provided NASA with an unmissable opportunity, a chance to explore multiple planets in a single mission. Seizing this moment, the space agency launched the twin Voyager probes, setting them on a course that would redefine humanity's understanding of the outer planets. Voyager 1, despite launching second, overtook its sibling thanks to a more direct trajectory, accelerating to 38,000 miles per hour, outpacing Voyager 2's 34,360 miles per hour. Just 13 days after launch, Voyager 1 captured an unprecedented image of Earth and the Moon from 7.2 million miles away, a snapshot that symbolized the beginning of an unparalleled voyage. By 1979, both probes had reached Jupiter, uncovering details never seen before. They detected a faint ring system around the planet and discovered 3 previously unknown moons. The probes also resolved a long-standing debate, confirming that Ganymede, not Titan, is the largest moon in the solar system. Close-up images of Europa revealed a smooth, ice-covered surface scarred by cracks, fueling theories about an ocean concealed beneath the frozen shell, an idea that would shape future missions in the decades to come. Jupiter's Great Red Spot, a colossal storm churning for centuries, was observed in unprecedented detail. But Jupiter was just the first step. Using the planet's immense gravity, both probes accelerated toward their next destination, Saturn. By 1980 and 1981, the probes arrived at Saturn, capturing intricate details of its magnificent rings. Far from being uniform structures, the rings were composed of countless narrow bands, some braided together in complex patterns. 4 new moons were identified, but one in particular stood out, Mimas. Its pockmarked surface and enormous Herschel crater gave it an uncanny resemblance to the Death Star from Star Wars. Titan, however, was the real enigma. Wrapped in a thick, golden haze, its surface remained hidden. While visible light failed to penetrate its atmosphere, data hinted at something remarkable. Conditions similar to those that might support lakes or rivers of liquid methane. This discovery reshaped scientific thinking about where extraterrestrial oceans could exist. As Saturn's gravity flung Voyager 1 onto a new path, its mission took a different turn. Meanwhile, Voyager 2 pressed onward, heading for the ice giants, Uranus and Neptune. And what if Voyager 1's detour uncovered something unexpected while Voyager 2 ventured into the unknown? Keep watching to find out. Crossing the edge of the solar system. A long period of calm surrounded the Voyager probes as they ventured into the distant reaches of space. Then on August 25, 2012, Voyager 1 detected an abrupt change. The levels of charged particles from the sun dropped sharply, while cosmic rays from interstellar space surged. This marked a historic moment. The probe had crossed the boundary where the sun's influence ends and interstellar space begins. Voyager 2, moving at a slower pace, encountered the same boundary in November 2018. The sun's reach extends far beyond the planets, forming a protective bubble called the heliosphere. This vast region, stretching about 11 billion miles outward, is created by the solar wind, a continuous stream of charged particles. At its outermost edge lies the heliopause, the invisible boundary where solar influence gives way to the interstellar medium. Scientists once believed that the solar wind gradually faded as it moved outward. But data from the Voyager probes revealed a startling reality. Instead of a slow transition, the solar wind abruptly halts at the heliopause, curving sharply as it collides with interstellar plasma. The shape of this boundary is not uniform. One side appears almost spherical, while the other stretches into a long, trailing formation. More surprisingly, the heliopause is constantly shifting. Its surface is distorted by massive waves that ripple unpredictably, some spanning up to 930 million miles. This unexpected movement may explain why Voyager 1 and Voyager 2 crossed the boundary 6 years apart. Scientists expected the interaction between solar wind and interstellar radiation to create a significant rise in temperature and density near the boundary. However, the measurements showed values 10 times lower than predicted, raising new questions about where this missing energy had gone. Beyond the heliopause, interstellar space revealed itself to be colder and denser than anticipated, yet still influenced by the sun. Particles from both regions mix at the boundary, creating a dynamic layer of interaction. Shockwaves from the sun pass through the heliopause, disturbing interstellar plasma like supernova explosions do. These disturbances also led to another discovery. The interstellar magnetic field is 2 to 3 times stronger than previous estimates, exerting pressures 10 times greater on the heliosphere than once believed. The Voyager probes have redefined our understanding of the solar system's outermost edge, revealing a complex, shifting frontier where the forces of the sun and interstellar space continuously collide. The silent echoes of Voyager. As they journey deeper into interstellar space, the Voyagers continue sending signals back to Earth, offering valuable insights into their surroundings. But in 2022, Voyager 1, nearly 14.6 billion miles away, began transmitting strange sequences, long strings of zeros and the number 377. At first, scientists speculated whether these signals carried hidden information. Eventually, they identified the issue as a malfunction in the spacecraft's attitude control system, likely caused by cosmic radiation. Though the probe could still be controlled manually, it had lost precise awareness of its orientation. NASA engineers resolved the problem by rerouting telemetry through a secondary onboard computer, restoring stability. A more concerning silence followed on November 14, 2023, when Voyager 1 stopped transmitting entirely. For 5 months, there was no response. The cause was traced to corrupted code in its computer memory, requiring engineers to relocate the data to a new section. On April 18, 2024, the team initiated this delicate process, but each command took 22.5 hours to reach the spacecraft and another 22.5 hours for a response. Finally, on April 20, 2024, contact was restored. Despite their resilience, the Voyagers are nearing their final days. By 2025, their instruments will begin shutting down as power dwindles. However, even after they fall silent, their journey will continue. Voyager 1, moving at 3.5 astronomical units per year, is heading toward the constellation Ophiuchus. In 38,200 years, it will pass within 1.7 light-years of a star in Ursa Minor, AC plus 7,938. Voyager 2, traveling at 3.1 astronomical units per year, is on course to approach Ross 248 in the Andromeda constellation in about 40,000 years. Though both probes cross the heliopause, they have not fully left the solar system. Scientists believe the sun's gravitational influence extends into the Oort cloud, a vast, icy region where comets originate. The Voyagers may take 30,000 years to pass through it completely. If intelligent beings ever discover them, they carry the golden record. Greetings in many languages, whale songs, and sounds of Earth. But if no one ever finds them, the Voyagers will continue their silent drift through the darkness, forever marking humanity's reach into the unknown, the cosmic bubbles that shape our solar system. In 1977, Voyager 1 and Voyager 2 launched from Cape Canaveral, embarking on a mission to explore the outer solar system. Though Voyager 2 launched first, its different trajectory caused it to reach the solar system's boundary 6 years after Voyager 1. As both probes traveled farther from the sun, they detected something unusual. The density of space was increasing instead of decreasing. Interstellar space isn't entirely empty. The solar wind, a stream of charged particles from the sun, has a density of 3 to 10 protons and electrons per cubic centimeter, which decreases with distance. At the heliopause, the solar system's outer boundary, this density drops to just 0.002 particles per cubic centimeter. Beyond it, calculations estimated interstellar space to have around 0.037 particles per cubic centimeter. Voyager 2 confirmed this at 17.9 billion kilometers, equivalent to 119.7 astronomical units from the Sun. But something strange happened. At 18.5 billion kilometers, the same as 24.2 astronomical units beyond the heliopause, the density increased to 0.12 particles per cubic centimeter, 3 times higher than expected. This phenomenon connects to an even larger bubble enclosing the solar system. In the 1970s and 1980s, astronomers noticed that space around the Sun appeared emptier than other regions of the Milky Way. Recent simulations by the Harvard-Smithsonian Center for Astrophysics confirm that the Sun and Earth are inside a massive void called the local bubble, spanning 1,000 light-years in diameter. This bubble formed about 14 million years ago from a series of approximately 15 supernova explosions. These blasts pushed interstellar gas outward, creating a structure with a dense outer shell. Initially, the local bubble expanded at 60 meters per second, but data from the European Space Agency's Gaia Observatory shows it still grows at about 4 miles per second. The bubble's outer edges contain at least 7 star-forming regions, dense molecular clouds where new stars are born. Astronomers believe many such bubbles exist across the Milky Way, suggesting other stars and planets may be enclosed in similar structures. The Sun wasn't always at the bubble's center. About 5 million years ago, as it orbited the galaxy, it drifted into this position. Understanding cosmic bubbles helps reshape our view of the universe. Astronomers compare space to Swiss cheese, where supernovae carve out cavities and new stars emerge along their edges. Mapping more of these bubbles could reveal how they shape galaxies, influence star formation, and interact with one another. The density increase detected by Voyager 2 hints at complex interactions between solar plasma and interstellar plasma at the boundary, raising new questions about the forces shaping our cosmic neighborhood. And what if Voyager 2's discovery reveals hidden forces shaping our cosmic neighborhood in ways we never imagined? Let's keep watching. The cosmic haven shielding Earth. Imagine 2 powerful streams colliding at unimaginable speeds. At the point of impact, chaos unfolds. A dense accumulation of particles forms, much like a traffic jam. This congestion occurs at the boundary of the heliosphere, where solar and interstellar winds clash, creating a protective barrier around the solar system. Beyond this boundary, at a distance of 0.75 to 1.5 light-years from the Sun, lies the Oort cloud, a vast spherical collection of icy bodies, potentially numbering in the trillions, serving as the source of long-period comets. Although interstellar forces dominate here, the Sun's gravitational grip still holds on to these distant objects with its last remnants of strength. Some might wonder what it means to be surrounded by both the heliosphere and the local bubble, 2 immense cosmic structures. The smaller of the two, the heliosphere, plays a crucial role in shielding Earth from high-energy cosmic radiation streaming from the center of the Milky Way. Without this protective layer, these deadly particles would bombard our planet, threatening life as we know it. The local bubble, however, reveals an even grander cosmic picture. Scientists have long understood that the Milky Way is a spiral galaxy, with its arms extending outward from the center. Currently, the Sun is positioned between the Sagittarius and Perseus arms, journeying through space at a pace that completes 1 full orbit around the galaxy every 200 million years. A single galactic year. In the course of its movement, the Sun has crossed multiple interstellar regions, encountering dense accumulations of gas that have significantly influenced Earth's history. Astrophysicist Miroslav Filipovich discovered a correlation between these crossings and 5 major extinction events: 415, 322, 300, 145, and 33 million years ago. Each time the Sun traversed these dense galactic arms, life on Earth faced catastrophic upheavals. At present, however, the Sun drifts through the local bubble, a low-density region that offers a rare period of stability, an era that has allowed human civilization to emerge and flourish. This cosmic void not only gives humanity a clear, star-filled sky, but also minimizes space dust, making interstellar travel less treacherous. It's as if the universe itself has cleared a path, inviting future explorers to journey beyond the solar system. But what do you think? Will the Voyagers uncover something more groundbreaking beyond our solar system? We'd love to hear your thoughts. Stay tuned for more cosmic discoveries, and don't forget to like and subscribe.